Well, we're in week 4 of the semester, our exam 1, week 5. And exam 1 will be focused on kinematics, plus a little bit of structure, function, performance type of work that we covered. And so this week we are wrapping up the overview of kinematics, looking at angular position. And that will tackle both linear kinematics, which we've been doing the last couple weeks, and now angular kinematics. You'll find that the mathematical relationships between angular position, angular velocity, and angular acceleration are exactly like linear kinematics. And the equations are very similar, just different symbols. The key difference between linear and angular kinematics is the way that we quantify angular position. And you'll see this presentation on angular position that's focused on that. You've also already been exposed to one presentation on angular kinematics as well. But really good to understand the different ways that we can quantify angular kinematic position. And then I add in some angular PVA information here as well to sort of give you that graphical representation of the relationships between angular position, angular velocity, and angular acceleration. Okay, so for the videos this week, let me change my share here. For the videos for this week, we're in angular kinematics, and then exam 1 next week, week 5, which will cover both linear and angular kinematics. So I've got angular position here, and just as I said, this is one of the key differences between linear kinematics and angular kinematics is the different ways to quantify position in the angular world. So I go through absolute and relative angles quite a bit in this presentation. I did put this one up here, which you've already watched. That would have been week 2 of the semester. And this is the overview of kinematics. Good to have some repetition here. So go back and watch this video again, and you'll get both the linear and the angular kinematics presented all together. And then I added in some angular PVA information. We're giving you that specific graphical relationship or showing the graphical relationship between angular position, angular velocity, and angular acceleration. I really value being able to look at graphs, be able to interpret graphs, and see how these different parameters are related to each other. I did add a presentation on some math problems, reviewing that with exam 1 coming up. There will be some math, but the pure math questions on the test are probably 10 to 20% of the questions, where I actually have you calculate something. Generally, in the exam, I'm more interested in your ability to pick the correct equation, to have the right units for each parameter, and to know the equations for each parameter, so or definitions, equations, and units. All right. There are some math questions because I want to see if you can apply the tool of the equations that we've gone over in a way to come up with an answer to some question. And what's the final position if initial position is this and velocity is that and time is something this, that type of thing. And so I go through a couple of problems, and you'll hopefully see the pattern of how these problems will be presented, and you'll be able to work through them. Don't think of the test as a math test. So go in, if you're prepping for the exam, you're thinking definitions, equations, and units, and trying to interpret graphs, understand graphs, so you'll do well on the exam in that approach. And then I did add in a presentation on angular kinematics application. I do really value that we do not want to lose sight that the information we're going over is actually very useful for us as we go forward in our kinesiology degree or as you go off working in the sports industry. And so this is a presentation talking about different ways we use angular kinematics in the laboratory. Okay, I hope that's helpful. As always, I'll have the Monday, Wednesday Zoom rooms. Please join those if you want to ask questions about this material or any material that we've covered or where we're going. All right. It's a good way to understand the content a bit deeper than what we're doing in going through these videos. All right. Thanks, everybody.